We have trig ratios that we did SOHCAHTOA with, correct? In the past? But now all of our, I don't adapt, it's a thing. Now all of our triangles will always be on a Cartesian plane. So for example, if I use this triangle, because here's my terminal arm, see how that's a terminal arm there? If I use this triangle, the angle is always the central angle, so this would be my theta. Okay? This is my 90, so what is this always? Hypotenuse. And if it's a central angle, what's this always? My adjacent. And then this is the angle that is opposite it. We agree? Because we're sitting in a Cartesian plane, we don't use adjacent, opposite, and hypotenuse anymore. We use x, y's, and r's. X for the x value, because it's on the x-axis. Y for the y value, because it's on the y-axis. And r for radius. Yes? So what would this adjacent be always? X, because it's the x, correct? And even if I moved my triangle over here, I would use a central angle. This would still be x. This would still be my adjacent. It doesn't change. We agree? So x's are always adjacents. Opposites are always what? Y's. And hypotenuse is your r. Doesn't change. So we're no longer going to use SOHCAHTOA. We're going to use sine theta equals y over r. Now the other thing is, do you see this theta? You don't have the word theta beside sine. It is the word sin. It is not the same thing. Sine is a trig ratio. Sin is not good. You know what I'm saying? All right. For those of you who say cos, this does not work out well in my favor because this is cosine. So you say cos of theta if it has a theta. If it doesn't have a theta beside it, it is cos, which doesn't work for you weirdos who say cos theta because you don't make my thing make sense. Okay? So it's cosine theta, right? If it has a theta symbol. If it doesn't have the theta symbol or an angle beside it or a variable beside it, it is the word cos. It's not cosine. Those are totally different things. Same thing with tan. This is just tan, but if it has a theta beside it, it's actually the trig ratio tangent, right? So that's what you have to remember, the thetas beside. People just write the word and they don't put the thetas beside. The theta beside either means I'm going to have a theta beside to find the angle, or if I have an angle, it's going to go in for theta. Okay? So you need that, and people forget it. So I have stupid acronyms to help you out. They were made like 10 years ago. Some of them aren't even me who made them up. So in order for, you're like, these are dumb. You'll be saying them. It'll happen. You'll be saying these stupid acronyms in a few seconds. So sine, it makes sense because sine would be SOHCAHTOA, right? So this would be opposite over hypotenuse technically, correct? And opposite is always y and hypotenuse is always r, right? So it makes sense that it is. The acronym I use is sign your resume. You don't actually sign your resume, but that's okay. Caden does, so it's okay. Sign your resume. And then when in doubt, cook extra rice, because who wouldn't want fried rice after a meal of rice? Yeah. And then, since Xboxes run out of vitamin D, you should tan them. Tan your Xbox, so it doesn't get scurvy or something, you know? Put it out, let it tan for a little bit. Pardon? That's what I thought. All right, so it's sign your resume, cook extra rice, tan your Xbox. Okay? Sounds like an issue, not an ish me, you know what I'm saying? Yeah. Okay, I like that. All right. Then there's these lovely secondary reciprocal trig identities. Yeah, I know. What's better than 3 trig identities? 6. That's what I say. So, cosecant, it's always bad when on a test people are like, I don't remember if cosecant is reciprocal of sine or of cos. There's this crazy thing called the formula sheet, which tells you. So if you get them wrong, it's because you literally didn't look. So cosecant is 1 over sine. We agree? And then secant is 1 over cos, cosine is 1 over tan. Well, what the heck does that mean? Well, if I know sine is sign your resume, I would have cosecant theta technically is 1 divided by, and I'm going to put it sideways if it's a fraction because I'm going to flip, sine theta. We agree? That's what it says on the formula sheet. Then cosecant theta equals 1 divided by sine your resume. We agree? What do you do when you have a fraction with a division? You multiply by the reciprocal. You flip it. So I would get cosecant theta equals 1 times r over y. So cosecant theta is just r over y. So that's why they're called the reciprocal trig identities, because whatever sine is, cosecant is the flip of it. It's the reciprocal. Okay? So if you know the 3 acronyms, is it hard to know the other 3? No, they're just whatever the heck the other 3 are flipped. Not sign changed, nothing, just flipped. Right? So on our unit circle, I drilled into your heads yesterday, on your unit circle, it's cos theta, sine theta, correct? So off your unit circle, is it really easy to get a cos theta? Like cos of 30. Yeah, it's root 3 over 2. Sine of 30 is a half. You can pull them right off your unit circle, right? Because it's x and y. So what's secant of 30? It's just cos flipped, correct? So it'd be 2 over root 3. And what's cosecant of 30? It's just sine flipped, 2 over 1, right? So cos and sine are really easy to pull up your unit circle. So are secant and cosecant. They're just the flip of them. They're just whatever the heck they are flipped. We're going to talk about that right now. Ignore this stuff. We're going to talk about this in a second. So I want to just share that home with you. So I want cos of 60 degrees. I want sine of 60 degrees. I told you to have your formula sheet and your unit circle out now till the end of time. You should really do that. And then cosecant of 60 degrees. And then secant of 60 degrees. Cos of 60 is what? Cos of 60 is 1/2. So cos is cook, extra rice. We agree? Just proving a point here. Cos's bestie is secant. Sine's bestie is cosecant. So C's goes with S and S goes with C. They never go with each other. You can memorize that if you so choose. Or look at your formula sheet because it literally tells you on it which one's goes which. Right? It shows you it's the reciprocal of the other one. Okay. So if cos is cook extra rice, then secant is rice extra, which means it is 2 over 1. Do I have to write it as 2 over 1? Write it as 2. Okay. Then we have sine. Sine of 60 is root 3 over 2, and it's sine your resume. So cosecant is resume your. So it is 2 over root 3. The catch with that is you always have to rationalize your denominator. So you have it equal to 2 over root 3. We learned that if we have a monomial radical in the denominator, we just multiply by that monomial radical. Yes? Because, paying attention? Your name rhymes with Schmeiko? Don't know who that is. Anyways, root 3 squared would come out to what? 3. Because when you square the square root cancel, I'm left with a 3. We agree? So that's the same as root 3 times root 3, which is the same as root 9, because you learned in grade 10 that you multiply coefficient by coefficient, radicand times radicand, which is still 3. Okay? Big old rules that you learned. Now, in grade 11, we learned to rationalize. So we multiply by that monomial, and we get 2 root 3 over 3. Okay, last 2 trig ratios. We've only done 4 of them. Just so you know, the other 2 as well come from your unit circle. Okay? Tan and cotan. So what can I pull off the unit circle? What have we talked about? All right. What can I pull off the unit circle? Cos and sine. We agree? Mm-hmm. We know that secant and cosecant are the flip of cos and sine, so therefore we can pull them off the unit circle as well. So look at the very top of your formula sheet. The very top, not this random formula that we're going to do at the very end. This one, tan and cotan. Do you see it? What do they have? Tan is sine theta over cos theta. Can I pull those off my unit circle? Yep. And cotan is cos over sine, which makes sense. It's the reciprocal of it, right? So, off my formula sheet, tan says that it is what over what? Sine theta divided by cos theta. Why would I write them sideways? Yeah, because they're fractions. But if it's on the arms, like on the 0, the 90, the 180, the 270, you don't have to write them side by side because those are like 1 and 0, correct? But remember, if it's 0 over 1, what's 0 divided by 1? 0 divided by 1 is 0. What's 1 divided by 0? Undefined. You can't divide by 0. Remember rationals in grade 11? You guys would have like a number over x plus 3. And then you had to give the non-permissible values for this because this could not equal 0. So you would go x can't equal -3, or it would turn my denominator into 0. You can't divide by 0. It's illegal in all states, territories, and Mars. So if you divide by 0, it's undefined. So for this one, if I want tan of 60 degrees, sine, what's sine of 60? Root 3 over 2. So this would be tan of 60, this would be sine of 60, cos of 60. These would all turn to 60s. We agree? You would erase them on a test, please, but point proven. So it'd be sine of 60 divided by cos of 60, which is a half. So tan of 60 equals root 3 over 2 times 2 over 1. The 2's cancel, and I'm left with root 3. What would cotan of 60 be? In the end, yes. Because you would flip it, correct? Or you could write it out, you could either flip this and make it be 1 over root 3 and then rationalize it as root 3 over 3. Or you could write out cotan of 60 degrees equals cos of 60 degrees divided by sine of 60 degrees, which is a half divided by root 3 over 2, which is a half times 2 over root 3, which equals 1 over root 3. Could have done that. Or you could say cotan is the flip of 1 over root 3. Like this, flipped, the reciprocal, and then rationalize it. Either way, same answer. So do you see how I can get exact values of every single 6 of the 6 trig ratios off of my unit circle? Yes. All right. We're going to go back to our notes. I was just proving to you that we can do that. That's all I wanted to prove to you, is that all 6 trig ratios, if I ask for exact values of 30, 45, 60, or 90s, reference angles of the whole circle, you can give me any of these answers. All right. Back here. You guys talked about the CAS rule last year. Sine and cosecant are besties, so they follow the same rules. Cos and secant and tan and cotan. Well, why would that be? Well, if sine theta, let's for example, sine theta was positive 1/2, cosecant theta would be positive 2 over 1, right? Their signs wouldn't change in that quadrant. So whatever rule follows for sine, cos, and tan follows for secant, cosecant, and cotan. It's best friends. So CAS says we start in quadrant 4. So you can either start in quadrant 4 and you can do CAS. Or you can start in quadrant 1 and say all students take calculus, which is false. That's okay. All students take calculus if you want to start in quadrant 1. Okay? Well, what the heck does that mean? That means every trig ratio will be positive here. This one means sine and its bestie cosecant will be positive here. Tan and cotan will be positive here only. And then cos and secant. Now, I don't think people truly actually understand what the heck that means. So, let's look at this. If I picked a coordinate here, and the coordinate was -3, -4. Let's pretend that's my coordinate. Okay? That's my x and my y. We agree? Tan is tan your x box. So it would be -4 over -3, which means that it's going to become positive. Yes? Cotan would be -3 over -4, which is positive. Yes? The other ones we're going to have to get the radius for. And your radius is a length of measure, so it'll always be positive. So if I do x divided by the radius, it would be -3 divided by the radius, which is 5. We have a bomb there. That's okay. That's going to be negative. Or -4 divided by 5, that's going to be negative. So every other trig ratio, sine, cos, cosecant, secant, will end up being negative trig ratios. So the only thing that's positive there is the word. Tan, cotan. Here, the only trig ratios that would come out positive would be cos and secant, sine and cosecant, and everything's positive here because the coordinates here are all positive, right? They be positive, positive. All right, let's show that in actual math. So here, it says, given the following point on a terminal arm of some rotational angle, find the exact value for all 6 trig ratios and the rotational angle to the nearest degree. Now, all we're going to do right now is literally just get the 6 trig ratios. We're going to practice that, and we'll come back to the rotational angle. Because too much at one time isn't a good thing always. Like ice cream, you know what I'm saying? All right. So the first thing we're going to do, which I have to try and get everyone to do, is sketch this. The people who sketch this will often get everything correct. The people who don't sketch it will often get something wrong, especially when we start doing trig ratios. So we have -2, -6. Let's plot that. -2, 1, 2, 3, 4, 5, 6. Now, guys, we always plot this with the terminal arm coming out of 0, 0, and it always forms a bow tie angle. So we're always going to go towards the x-axis, our triangles. Okay? Now let's put what we do know. What is x? X equals -2. So I'm going to put that here. What is y? -6. So this line here is -6 long. Do you see that? So y equals -6. How do I find the radius? What kind of triangle is this? It's a right angled triangle, correct? So if I have x and I have y, what am I finding? The hypotenuse, which happens to be what? Canceling. R. So let's find that third side. So we're going to get r squared equals x squared plus y squared. R squared equals 4 plus 36. R squared equals 40. You take the square root. When we take the square root, what must we always do? Use our hands plus minus. So I get r equals plus or minus root 40. Let's break down root 40. Let me do it here. Root 40 breaks down into what and what? Root 4 and root 10. Because those multiplied together make 40. So I have an equal sign. And if I put root 40 into my calculator, and I put root 4 times root 10 into my calculator, they give me the same decimal, because they're the exact same thing. Okay? And then the square root of 4 is 2, and the square root of 10 stays square root 10. That's why in grade 10, when people didn't know if they got it right, I was always like, I don't know how you don't know if you got it right. Put root 40 into your calculator, put 2 root 10 into your calculator. If they come out the same decimal, you got it right. If they didn't, you're wrong. Yeah. So, r has to equal 2 root 10. Not negative. Because a radius is a length, and length is a distance, and distances can't be negative. So your x and y can be positive or negative, so when drawing them in the quadrant, they'll figure out what they need to be. But our radius is always positive. So we're just going to do our 6 trig ratios. Like I said, we'll do the rotational angle after. So sine theta is what trig ratio? Sine your resume. So what is your y? -6. What's resume? 2 root 10. What do I have to do still? Rationalize and then reduce. So I'm going to multiply by root 10. I don't need to multiply, I don't know why it's, I don't need to multiply by the 6, or the 2, because that doesn't matter. I just need to get the root 10 to go away. So now I have negative 6 root 10 over what? Root 10 times root 10 is? 10 times 2 is? 20. And then I need to reduce my coefficients, right? Take a 2 out of both, so I'm left with negative 3 root 10 over 10. Done. So that's sine theta. What's sine besties with cosecant? So I don't take my answer and figure it out. I just take what I had here and flip it, correct? So if it's sine your resume, cosecant is resume your. So I'm going to get 2 root 10 over negative 6. Just the 2 flipped. We agree? What's great about this one? The radical's in the top. So I just need to reduce and call it a day. Now, if you left the negative sign on the bottom, you wouldn't be wrong, but more often than not, they'll move it to the top, right? So they're going to get negative root 10 over 3. Okay, our next one is cos theta. Cos is cook, what? Extra rice. So x is negative 2, rice is 2 root 10. Am I done? Am I done? No, I need to rationalize. I'm going to go root 10, root 10. And so I get negative 2 root 10 over 2 times root 10 times root 10. Root 10 times root 10 is 10. 2 times 10 is 20. And then I need to reduce. Take a 2 out of both of those coefficients. And I get negative root 10, or negative 1 root 10 is totally fine, over 10. That's cos. Secant. So if cos is cook extra rice, secant would be rice extra, right? It's just the flip of it. So I would get 2 root 10 over negative 2. Now you could write that as root 10 over negative 1, but is anyone going to write that on the test? No. They'll move the negative up, so these will cancel, and they'll move the negative up, so they'll write it as negative root 10. And then our last ones are tan and cotan. Tan theta is tan what? Tan your what to get it vitamin D? Your X box. So you're going to tan your X box. It's negative 6 over negative 2, which is 3. And then cotan is the opposite of tan your X box. It's the reciprocal of it. So instead of tan your X box, it's X box your. Negative 2 over negative 6, which is a third. Make sense? Okay, we're not doing the angle right now. I told you that. We're going to flip over. There's 2 examples on the back. What do you think I want you to do? Do them. So we have X, we have Y. The first thing we're always going to do is draw a diagram, even if you think it's easy. 2, 3, 1, 2, 3, 4. It's here. We make a bow tie with it. We're coming from center up. So our Y is negative 4. Our X is 3. And this is the greatest thing ever because our R is 5. It'll always be one of these. So we get 3 squared plus negative 4 squared. R squared equals 9 plus 16, which is 25. Square root plus or minus. If you forget the plus or minus on here, you'd luck out because our R is always positive. So our R equals 5. That's the greatest thing ever because you're not going to have to rationalize anything. Yes? So they should be quick. So it's sine theta. Now check. Are you sinning on your page or do you have a theta beside it? Because if you're just sinning, life is not good. Check. There's going to be people who do not have thetas beside their sin. So just be sinning away. Yo. I have to reply to Sam. That made me laugh. It was his email. It was like, dear, to whomever this may concern, this is you. And then he just kept like writing stuff. And he's like, yours truly, most humble. It wasn't like that. I did see it. Tell him to come in at lunch. Because you can't come in scheduled help because you guys have your grad credit check. So we have sine, make sure you have the theta, your resume. -4/5. And it goes with cosecant. So it would be resume your, which I'm still going to put the negative on the top. Then we have cos theta. Make sure you have the thetas or you have the word cos on your paper. It's not the same thing. So it's cook extra rice, 3/5. Secant theta is 5/3. Please stop talking. And then tan your Xbox, so -4/3. And cotan theta is Xbox your, -3. All right. We're going to go down to this one. Coming back to the actual rotational angle at the very end, after we've done all these, we're just sticking to trig ratios. We're going to stick to what we know. Okay, so I could give you a coordinate. That is the easiest way I could ask for 6 trig ratios or any of the trig ratios by literally giving you a coordinate. You have to solve for r every single time. Yes? The other way is I can give you a trig ratio and then some other second piece of information that will give you the quadrant that it lands in. Now, the reason why you have to do that is a trig ratio will give you 2 places it could be, because with every single cast rule, say tan, for example, tan is positive if I use cast. Tan is positive here and here. We agree? Tan is negative here and here. So it's always going to get us 2 separate places. So we need a second piece of information to limit us to 1 quadrant. Okay? So for example, here tan is positive. Yes? You see that? So that first piece of information will land us into 2 quadrants. We always draw diagrams. People who don't draw diagrams do terrible on this question. So tan is positive, if I do cast quickly here. Tan is positive here and here. So I've limited myself to 2 terminal arms. But I need to limit myself to 1 terminal arm. Okay? So then they have to give me a second piece of information. This is the easiest way they could give me a second piece of information. Quadrant 1. So they kick this out. More often than not, they don't give you just like quadrant 1. Like that's way too nice, but we'll start that way. So we're in quadrant 1 and we need to draw a bow tie angle. Trig ratios always give you 2 things. They give you like x and r, x and y, or y and r, right? They'll always give you 2. You need to find the third. So what did this one give me? Tan what? Tan your Xbox. So it gave me a coordinate without giving me a coordinate. Did it not? Because in the last ones I always got x and y as well when it was a coordinate. If I get tan or cotan, it's like getting a coordinate because those are x's and y's. So they gave me y is 4. This is not drawn to scale. And x is 5. And then I always have to solve for the third side. Now with trig ratios, they're maybe not going to give me just x and y's. If they gave me cos or sine, they're not going to give me just x's and y's. They're giving me r's and x's or r's and y's. So I need to still solve for r. So I do r squared equals 4 squared plus 5 squared, or 5 squared plus 4 squared, it doesn't matter. And then r squared equals 16 plus 25. R squared equals 41. And then I take the square root and put plus or minus. So r equals root 41. And it has to be positive because it's the radius. Plus. So, cos, what's the trig ratio for cos theta? Cook extra rice. So I know this is going to be extra rice. So I need to do 5 over the root 41. And then I still have to rationalize my denominator. I'm going to get 5 root 41 over 41. Cosecant goes with what? Sine. So if it's sine your resume, cosecant would be resume your. So r is root 41 over y, which is 4. And then sine we have on the bottom because we have a theta beside it. Sine is sine your resume. So I'm going to get 4 over root 41. And then I have to rationalize. Okay. And we're going to look at 2. 2 is sine what? Sine your resume. So I know they gave me y and r. I know I'm going to have to find x. And the catch is if I do not draw this, my x can be plus or minus whatever the heck it is, and I won't know which one it is. Now I'm going to 50-50 guess. I'm going to get it wrong. Okay? I have to try to find out what quadrant it's in, and then what quadrant it's in tells me if it's x or y. So I know this one gives away the quadrant. I don't care. I'm going to do it properly. So it's sine. This ratio is positive. We agree? So when I go to use cast, where is sine positive? Where they're all positive, which is quadrant 1, or where sine is positive, which is quadrant 2. Correct? Then this is a giveaway, but like I said, they're not often this nice, and by not often I mean never. 90 degrees to 180, 80 popped off because of the degree symbol, because of the table. 90 to 180 is what quadrant? 2, because this is 90, this is 180, right? So it kicks out this one, so I'm drawing it here. So we know y is 3, we know r is root 10, and because I'm drawing it, I immediately say x equals negative something. And I put the negative there right away to remind myself to make it negative, because you guys will forget. Okay, because it's in quadrant 2, x has to be negative, because we're drawing this coordinate technically right here, which would be negative x, positive y. Okay, so we have to do our solving, so we're going to have x squared equals the radius squared minus the other side squared. So I'm going to get x squared equals root 10 squared. That just cancels out the square root sign. Minus 3 squared. So x squared equals 10 minus 9. X squared equals 1. And then I have to take the square root plus or minus. And x equals negative 1. And why do I know it's negative 1? Because I drew it. We agree? All right. Let's do our trig ratios. So it's tan your x box. So this one's going to be 3 over negative 1. So it's negative 3. Cosecant is friends with what? Sine, right? And sine is sine your resume. So cosecant is resume your. So it's going to be root 10 over 3. Done. And cos is cook, extra, rice. So it's going to be negative 1 over root 10. And then I have to rationalize. All right, I'm going to flip over. So those ones nicely gave me the quadrant. One gave me a restricted domain quadrant, one gave me one. This doesn't give me the quadrant, but it does give me two pieces of information. It says sine is what? Sine is negative, and tan is, what does this mean? Positive. So when I go to draw my quadrants, I have C, A, S, T. I need the quadrant where sine is negative and tan is positive. Anyone know where that is? Everyone look, and I want you to think, and then we're going to give the answer. I want where sine is negative and where tan is positive. So sine is negative in quadrants 3 and 4, right? And tan is positive in quadrant 3. So if I went to draw the arms, let's say, sine is negative here and here, tan is positive here and here. Where did the arms double? Quadrant 3, right? So I'm drawing it in quadrant 3. It's where they both exist. Does that make sense? Do I have people? Did I lose anyone? All right. So I'm drawing my triangle here for the arms doubled up. And this is sign your resume. Now guys, they'll often give it like this. They put the negative in front, but they'll often go like this. I don't know why I just put a Y. They'll often say 2 over negative 3. And then people will say, okay, Y is 2 and R is negative 3. Can R be negative? No. So what do you have to say? Actually, nice try, but the negative sign has to be up here and you have to move it. Okay, do you see that? And if you draw it in quadrant 3, you'll catch that. Look, I know, this is a Y. Y has to be negative something, negative 2. And X is going to have to be negative something because it's in quadrant 3. We agree? And then, I just wrote those wrong. Y is not negative 2. What is Y? Yeah. Y equals negative 2. I think I had that. I think I'm losing my mind. R is 3, and then X is something. So X squared equals 3 squared minus negative 2 squared. X squared equals 9 minus 4. X squared equals 5. Plus or minus. Is it plus or is it minus? This one is minus. Sometimes it's plus. A lot of times it's minus. And if you don't draw it, you won't know which it is. You'd be 50-50 guessing. So you guys do 3 and 4. Okay, you guys keep working through, but I'm going to show what the answer is. So cos is cooked extra rice. So I'm going to get negative root 5 over 3. Cosecant is sine flipped. Sine is sign your resume, so this is resume your. So I'm going to get 3 over negative 2. And cotan is tan flipped, so tan is tan your x box, so this is x box your. So I'm going to get negative root 5 over negative 2, which is root 5 over 2. Okay, this one is cos, cook extra rice. Now guys, I need you to pay attention for 1 second here. You see how this is cos theta equals, and then whatever it equals on the right side can be extra rice? What I'll get you guys will do this. You'll go cos of 7 pi over 6. And then you'll say, oh, this is x over r. That's not true. This is an angle. It would equal x over r. That would be a true statement, but this doesn't equal x over r. This is your angle. It's like cos theta equals x over r. Right? That's a radian measure. That's just an angle. Okay. So I need cos to be negative, and I need tan to be negative. So where is cos negative and tan negative? In quadrant 2. So where they're both negative. It's going to be here. I have x equals negative 5. I have r equals 13. And y, I believe, is 12. So y squared equals 13 squared minus negative 5 squared. Y squared equals 169 minus 25. Y squared equals 1.4. Square root plus or minus, square root plus or minus. So y equals 12. positive 12, because it's in quadrant 2, y has to be positive. So sine is sine your resume, so it's going to be 12 over 13. Secant is cos flipped. Cos is cooked extra rice, so this is rice extra, which is 13 over negative 5. And then tan is your x box, so I'm going to get 12 over negative 5. You can leave it like that, or you could write it as negative 12 over 5 and have a negative sign in front, or you could write it as negative 12 over 5. Those are the same thing. Now, example 3, like I said, I want you guys to do this for homework. I'm going to explain it to you. This is what we did at the very beginning, where we did it as a side note, right? I want tan of pi over 2. Sine of pi over 2 is really easy to find. Cos of pi over 2 is really easy to find. Those are your x and your y on your unit circle, correct? So tan of pi over 2, you have to somehow use the unit circle to get that. Remember on your formula sheet, the second formula down on the right-hand side is gives you tan is sine over cos, and tan is cos over sine, right? So if I want tan of pi over 2, that just equals sine of pi over 2 divided by cos of pi over 2. Sine of pi over 2 is what? What is the y at pi over 2? 1 divided by 0, which I could actually write this way. Am I allowed to do 1 over 0? What is that? Undefined. Put tan of pi over 2 in your calculator, because you can check these. What do you know? What mode do you need to be in? Radians. So tan of pi over 2 is what? Is it error? Yeah, because it's undefined. So what is cosecant of 7 pi over 6? Cosecant of 7 pi over 6, I don't know, I'm rewriting it. Cosecant of 7 pi over 6 equals 1 divided by sine of 7 pi over 6 off your formula sheet. We agree? So it's just whatever the heck sine 7 pi over 6 is flipped. So it's 1 divided by what? What is sine of 7 pi over 6? What's the y at 7 pi over 6? It's on your unit circle. Same place as 210, 30-degree reference angle. There's a 1 over something, negative a half. So it'd be 1 times negative 2 over 1, which is negative 2. And once again, you can check this. How do I check cosecant 7 pi over 6? I type in this. 1 divided by sine of 7 pi over 6, right? Because I have a sine button, but not a cosecant. So I want you guys to attempt these for tomorrow. It's cos 225 squared. It's just the same as cos 225 degrees squared. These need to be done for tomorrow. This is your homework. Done for tomorrow. Attempt it for tomorrow in pencil.